I done doed it the other night. All right. GT-108. Now that I more thoroughly understand it, this is just an excellent design, and I can't wait to receive it even more. Let's once again trace the signal path, and I'm going to use my mouse to do so, right? You have to follow my mouse here, okay? So the input is right here. Now on startup, this capacitor right here charges through a voltage divider, and this transistor controls the process. But anyway, this voltage right here called sound, by virtue of being discharged and charging C22 through this voltage divider and controlled by this transistor Q8, controls the gate of this JFET. And initially on startup, while the amplifier's warming up and everything's capacitors are charging, this JFET turns off, or I should say, shorts to ground. And so the input signal, there's a 1K there, so it doesn't short the input signal, but basically the base of this transistor is grounded, and no signal can pass through. So if there's any noise coming in, or even if someone has their preamp turned on, it's not going to cause any instability in the amp, and it won't cause anything to bleed through to the output. After a certain period of time, this JFET will open up like an open switch, controlled by the charging and discharging of this capacitor. Okay, I'm going to keep it broad. And then once this opens up like an open switch, then the input signal can go right through to the base of this transistor right here, into this complementary Darlington type pair. All right. But it really doesn't matter. This is a complementary Darlington. This is a differential amplifier. Just that's all it is, a diff amp. All right. Now, interestingly, what this is up here, this is a voltage regulator, and there's a Zener diode here and some other circuitry, and all this circuitry does, VCC is around 70 some volts. I forget exactly, 72, something like that. V-mid comes out. It's a regulated power supply, basically, a regulated voltage supply. V-mid comes out, and it comes in down here to establish a midpoint, because we have ground here, and VCC up here, which will be, let's just call it 70 volts. It's probably a 72 or something like that. So this will establish a midpoint between the two, 35 volts, let's say. It's probably 36 or something. And so this establishes a midpoint right here at the base of this transistor. This capacitor blocks that from feeding it back into the source. To ensure that we have a nice voltage swing at a midpoint, to ensure that everything can swing positively and negatively equally, regardless of variations in the rail up here. That's all that this does right here. All right. So our input signal comes in. Here's our input ground right here. So if we had our RCA jack, this would be the little center part of the jack, and the outer portion would be ground. So we have our audio signal that comes in here. Let's say everything's warmed up. And by the way, let's start with the warm-up process. This stuff over here is basically the sophisticated timer that's ultimately going to control the relay. This is K1's the relay, and you can see K1 is up here. So after a certain period of time and under other conditions, it'll turn that relay on and off. So all this stuff here, and here's VCC up here. This is the rail voltage, and here's ground down here. So this will control the relay to turn on after a certain period of time. You'll hear that relay click, click. Power amp is on and ready. So two things happen at warm-up. This JFET shorts down to ground and allows the signal to come in, and this relay closes and allows the output signal to go out to your speakers. Signal comes in to the diff amp, and also, see V out right here? The output signal is fed back. You don't see a wire here, but there's going to be a wire or a trace. Here's V out. The output signal is fed back to the other side of the differential amp, and that's our negative feedback. And remember, a differential amplifier subtracts, the two signals, and takes the difference. And here's our feedback resistor right here, and this will set the feedback, the amount of feedback we get. It happens to be a 20K feedback ratio. All right. So we have this differential amp, and it's going to provide a little bit of gain, but this is not the voltage amplifier. Remember, a power amplifier, power is voltage times current. So a power amplifier does two things. It will amplify first the voltage, and that'll be done, I'll show you in a minute, by these transistors here, and then it'll amplify the current, and that's by the output transistors. So we get a little bit of voltage gain, but the gist of what this diff amp does is it rejects common mode noise. So if there's any noise on your RC8 on your wires coming in that picks up that noise through the air, through the ambience, it'll be present on typically both the positive and the negative wires. It's common. And so if that, let's say you have a positive spike of noise there on the positive side and on the negative side, well, if it's the same on both, this will subtract this, the noise, and it'll cancel it out. That's what a diff amp does. Okay, so it rejects common mode noise, and it also allows for a way to also subtract out a little bit of the output for negative feedback. All right, now let's leave our diff amp, and here is where the voltage gain. This is, remember, a power amp, voltage, power is voltage times current. So first we need to amplify the voltage. It's done through Q12, Q13, and T6. And that's where we get almost all of our voltage gain in this amp, right there. Now that we've amplified our voltage, we get a nice big voltage swing. Now we need to amplify our current. Power is voltage times current. And we do that. This is our driver transistor, and this is our output MOSFET. And it's a class A, B, and we have complementary transistors right here. So, and I'm not going to get into detail. So this is one side of our complementary pair, and this is the other side of our complementary pair down here. So if we get a positive swing, let's think of a sine wave, like whoop, we get a positive swing here. The current, there's no voltage gain here. There's going to be current gain. So the voltage coming out here is going to be roughly the same, but this device here is going to be able to increase the current, or I should say, we'll be able to supply the current necessary to drive your 8 ohm load. Positive swing here, boom, boom, right on out. When you get a negative swing here, boom, current will come in, flow that way, that kind of thing. Now, bias is set right here at R57 and through some of this other circuitry right here. That's going to set our bias, meaning at idle current. We need to have a certain amount of current flowing. It's a class AB amplifier. So it needs to be biased slightly into class A while it's idling. So there's got to be some current flowing through these output devices. That's the class A portion of it. Just a little bit to bias it into class A. So we set that bias right here. And through a little bit of this stuff right here. Keep it simple. Also, down here, Q19 is actually attached to the heatsink, it's sandwiched in with I think this transistor right here, and it measures the temperature basically. Not measures, but it senses the temperature on the heat sink, and through through controlling this transistor Q21 up here, follows this path right up here, it will offset the bias in response to increases in temperature. Okay, so if the temperature starts to swing one way and it increases the bias, it'll this right here will reduce the bias in the opposite manner, and vice versa. That's all this stuff is right here. All right. Now let's get to this is the output blocking capacitor. It just blocks DC from getting to your speakers. Let's get to this, and this is the same down here. So I'll just talk about one channel. This is protection. I speculated the other day it was protection. It's protection. So this is a kind of this is an excellent designer. This person designing this and is quite brilliant as far as I'm concerned. This is a much more sophisticated protection circuitry than you're going to find in many standard Class AB amplifiers, because you're dealing with a guy this person is bringing in his knowledge of communications and bringing that into the audio world. And this is really good stuff here. And without getting too detailed, this provides many more levels of protection than just the standard old school protection stuff you used to see built in this area over here. And to make a long story short, I mean, this provides current protection, voltage protection, and some other things, but you see where it's connected, okay? So this transistor right here, let's just look at it as a switch that can open and close to make it real simple. And when this thing is like an open circuit, it's not doing anything. It's not causing any harm to happen. Not harm, but it's not affecting anything out here. The amplifier's happy, it's running. But under certain conditions that's being sensed, you know, let's call them overload conditions, faults. We don't want too much current flowing through this MOSFET to the point where it's going to damage the MOSFET. So what it'll do, this transistor will start, current will start flowing, and even to the point where this transistor might turn almost fully on. You can almost treat this like a closed switch. And if this were a closed switch, for example, look where this goes to. It goes to the base of the driver, and it goes all the way down to the drain of the MOSFET. And basically, we're essentially controlling the voltage here on the gate to stop the current from flowing, or limiting the current from flowing. Stop or limit the current from flowing through this MOSFET. That's it. Protection. And I think I've covered about everything. I mean, that's it. That's all. I mean, that's all the detail we need to go into. It's about all you need to know. But it's a very well designed amp, and there's no reason. These are both MOSFETs, and it's just the symbols. They don't need to be different. I think the designer just chose to use different symbols, but for whatever reason. But they are complementary, and it's a wonderful Class AB design. And I'm sorry that and what I wanted to point out with the comment that I read